that. All right, so here we go. Forgot to record at the start. So A goes over 0 and up 2, so it would be component form of 0, 2. B goes over 4 to the right and 0 up, so it'd be 4, 0. If we add A and B, it'd be a component form of 4, 2. If we subtract A and B, it'd be a component form of negative 4, 2. So you go negative 4, 2 to there. This is A minus B. This is A plus B. Okay? So, on your homework, you'll be told, well, what is A plus B? Well, we figured out A plus B is this. What is A minus B? Well, we figured out A minus B was this. All right. Now, A and B are going off at an angle. What's the component form of A on this one, Dylan? 2, 3. What's the component form of B on this one, Maggie?
5, 2.
How about 4, 2?
4, 2.
I know you're sitting a long ways back. Kind of tough to see. So then what would A plus B be? Maybe I should turn that down now.
6, 5.
Okay, 6, 5. What would A minus B be?
-2, 1.
Negative 2, 1. Okay?
What is that 2, 3? I'm so confused.
You 2 to the right and 3 up.
Oh.
Just like an ordered pair.
Okay.
4 to the right, 2 up. Okay. So, if you add the two vectors, 6 and 5 go there. Negative 2, 1 would be there. Okay? All right. Now, another way to do it when you're adding vectors is to use the head to tail method. Okay? This is the head. This is the tail. Okay? So if A goes this way and B goes that way, you draw B the same amount and it should end up about right there. Okay? Now, A plus B, if B ends up right there, then the resulting vector goes there. So that would be choice A. A minus B goes the opposite way. B would go the opposite way. Should be off this direction. So A minus B would be off this direction. That's called the head to tail method instead of adding up component form because we can't really tell where that is. Okay, it's hard to tell where it is to write down the component form. So we just use the head to tail method to figure that out. Come on. There we go. All right, magnitude and direction. Which one of these has a magnitude of 2 and a direction of 135 degrees? All right, so to be a direction of 135, you're 45 degrees past 180, or past 90 degrees. 90 plus 45 is 135. So you're over there somewhere. So you know it's not D, and you know it's not B. Which one of these two would have a length of 2? A would. That would have a magnitude of 2. Okay? Now, sometimes it's hard to know what the magnitude of 3 square root of 2 is. So we don't even bother with that and just look at the angle. Which one of these has an angle of exactly 45 degrees? E does, because if you go over 3 and up 3, that's an isosceles triangle, right? And isosceles right triangles are a 45, 45, 90 triangle. So E would have to be the logical answer. Which one would have an angle of 30 degrees? B would. Okay? All right, magnitude and direction of a vector. The magnitude formula. Okay? The magnitude formula is basically a magnitude is how long it is, which you could also substitute the what formula in for it? distance formula, which is the square root of the x squared plus the y squared. Okay? So it's basically the distance formula. I could make the Pythagorean theorem out of it. Okay? If you go back 2 and up 2 square root of 3, 2 square root of 3 is somewhere around there. I mean, you could make the Pythagorean theorem out of it. Negative 2, 2 square root of 3, and then that's x, so you could do the whole Pythagorean theorem to it. But, you know, this is the same way. Okay? So what's negative 2 squared? 4. 2 square root of 3 squared. You take 2 and you square it, and take the square root of 3 and you square it. What's the square root of 3 squared? 3. 2 squared is 4. 4 times 3 is 12. So it's the square root of 16, which is 4. So your magnitude is 4. Your direction. What direction does it go? How far is this? Well, this is where people tend to make mistakes in trig. So this is what I tell you to do. We're going to use reference angles, and we're not going to use the negative sign. Don't use the negative signs here. We're just going to know where it's at, what quadrant it's in, and then use reference angles. So if you're at negative 2, 2 square root of 3, you're in the second quadrant. So to find the reference angle, you take the inverse tangent of B over A. See how I didn't use any negatives? I dropped the negative sign off that and do the inverse tangent of B over A. If you do that, you're going to get 60 degrees, right? I'm glad you did it on your calculator and found that it was 60 degrees. Good job, people. So you're 60 degrees away from the x-axis. Which x-axis? From the 180-degree x-axis. So if you're 60 degrees away from there, this angle is 120 degrees. So the direction of your vector is 120 degrees. Let's do another one of those so you kind of get the gist of it. Okay? Magnitude. Easy peasy lemon squeezy. You just take the square root of 3 square root of 3 squared plus 3 squared. Don't need to worry about negatives because a negative squared is always going to be positive. 3 squared is 9. Square root of 3 squared is 3. 9 plus 3, 9 times 3 is 27. 3 squared is 9. So it's the square root of 36, which is 6. Magnitude, easy peasy lemon squeezy. To find the direction, what quadrant are we in if we go negative 3 square root of 3, negative 3? Quadrant 3, we're over here. Okay? So you take the inverse tangent of y over x without any negative signs involved. And you're going to get 30 degrees. Okay? So if you get 30 degrees, you're 30 degrees down from the x-axis because you always go from your x-axis for a reference angle. Okay? So if you're 30 degrees down from the x-axis, this is 180 degrees here. So where are you going to be at? 210 degrees for your angle. Okay? You got to know what quadrant you are at and what your reference angle is. If you're up here, you take 180 degrees minus your reference angle. If you're down here, you take 180 degrees plus your reference angle. This one is whatever you get on your calculator, whatever your reference angle is. And then this one, if you're here, you would go 360 minus your reference angle. Okay? And you get your reference angle by taking the inverse tangent of y over x. The inverse tangent of y over x. Okay? All right. What would be the magnitude and direction of that vector? First of all, magnitude. What do you think? Do you have to take the square root of negative 9 squared plus 0 squared? Well, that's the square root of 81, which is 9, right? If you're at something 0 or 0 something, it's just going to be the other number is your magnitude. Magnitude is going to be 9. But it's a positive number. Magnitude always positive. Okay? What's its direction? Where is it at if it's at negative 9, 0? How many degrees? Not 0 degrees. 180. It's over here. Negative 9, 0 is over here, right? So you're at 180 degrees. Okay? What if you were at 0, 4? What would be the magnitude? 4, the direction, 90 degrees, because you'd be straight up. Okay. All right, so I think you can get magnitude, direction. Last thing, let's do this one. 8u 10v. If u is this, v is this, what's your answer? Well, if it's 8u, you take 8 times 4, 3. And if it's 10v, you take 10 times 3, 8. So it's 32, 24, plus 30, 80. So it's 62, 104. Easy peasy, lemon squeezy. Okay? There are 14 questions. They are out there for you right now. After lunch, we'll do the second assignment, which is physics. You're going to go join physics class. You're already in physics, right? So this is all second nature to you.
What? What? Oh my goodness. That's it. Like, so what's about happening when you're like this? I think Kate's in it. She's in trouble.
Did you talk to him? I didn't.
Right? Said what?
Did you want to come and
Students. That was the.
Just say you can look